Good morning, children. Today we will start with the new chapter, that is chapter number 6. It is general principle for the extraction of metals from its ores. So, some idea of this you have already known, because in 10th standards also you have learnt this little about the metallurgy and how to extract metal from its ore. You have learnt it. When I say metallurgy, metallurgy is a branch where you are studying the extraction of a metal from its ore. Now, what is an ore? Ore is that mineral from where you can extract a metal in an economical way. Economical way means what? Without having much to spend, we can get the metal easily. So, our aim is to find the metal or to extract the metal with minimum cost. Okay. So, that is all involved in the metallurgy. When I say metallurgy, we are talking about the extraction of various metals like copper, iron, aluminium, zinc, then the other ones you can have is copper, iron, zinc, aluminium. These are the normal ones which you are going to learn. Calcium hai, magnesium hai, any of the metals you can talk about. But in this chapter we are going to learn about the extraction of the metal copper, zinc and iron. Mainly we are going to learn about that only. Okay. Now, metallurgy involves various steps we are having in the metallurgy. Okay. So, first step is to powder the ore, whatever ore you are obtaining, you are first powdering it. Okay. Then you are concentrating the ore, okay, by various concentration methods. There are different concentration methods discussed in your book. Then you have the next step is to convert the ores, the concentrated ores, which may exist in the form of a sulphide or of a carbonate or of an oxide. So, the next step is to convert the sulphide and the carbonate ores into oxide form, because reduction of oxide into a metal, oxide of a metal into metal will be more easier. Okay. So, next step will involve that. Lastly, after the conversion of the sulphide ore and the carbonate ore into oxide, then the next process would be the reduction process, where you are using a good reducing agent. Okay. Now, when you talk about reducing agents, the reducing agents also, the best reducing agent you have to choose. For that, the thermodynamic principles are used to understand how to choose the best reducing agents. Okay. And lastly, the refining process. Now, again refining this metal which you are obtaining after the reduction, which we call as the crude metal, that crude metal will contain a number of impurities, and that also has to be removed, and that is done by refining process. Various refining process you are going to learn. So, let us start with these topics one by one. Okay. So, metallurgy, when we say, it involves, the first step is to powder the ore. Okay. So, just grind the ore and you will get it in the powdered form. The second step is the concentration of the ore. Okay. So, we will start with that only. Okay, before going to the concentration methods for the concentration of the different ores, let us just go through which are the various ores from which the metals are extracted. For example, if you take the iron ore, the iron ore are of different kinds. Which are the ones? It can be a hematite, it can be magnetite, it can be siderite. Okay, it can be simple iron oxide. So, iron, when I say hematite, it is Fe2O3. Fe3O4 is the magnetite, siderite is FeCO3, and the simple iron oxide FeO. These are all the various ores of iron from where you can extract the metal. Okay. Copper, again you have copper carbonate, you have copper sulphate, you have copper oxide, copper sulphide, copper pyrite. Okay, copper pyrite, when I say, it has the formula Cu2 FeS2, CuFeS2, copper pyrite. Okay, it is in the sulphide form. When I say zinc, again zinc also exists in the carbonate form, in the sulphide form, in the oxide form. Okay. Then you have aluminium, which is having the main ore of aluminium is bauxite. So from this various ores, zinc has calamine is one of the oxide, then zinc blende is another ore of zinc. So there are number of ores which are given in your table that you can go through, and you can learn the names of the different ores with their chemical formula. Okay? The second step of metallurgy will involve the concentration of the ore. Once the ore is ground, it has brought into the powdered form, you have to concentrate the ore. Or we can, the word concentration ke jagah kahi book mein it will be written as benefaction of the ore. Benefaction of ore, concentration of ore, it is the same thing. The concentration of the ore is carried out by various methods depending on the type of the metal which you want and the impurity involved in it. Okay, so let us discuss about the concentration of ore. The concentration of the ore. Okay. The first method of concentration of ore is hydraulic washing. What is it? Hydraulic washing. Hydraulic washing. Now here what do? You wash the ore along with the metal and the impurity. That is, an upward stream of water is allowed to flow through the ore, the ground ore, and you will find that the principle used in hydraulic washing is the difference in the specific gravity. Okay, difference in specific gravity of the metal and the impurity. You may find that the impurity is more heavier than the metal, then impurities will settle while the lighter metal particles will flow away, or it can be the other way round also, that impurities are lighter than the metals. So therefore impurities will flow along with water, leaving behind the metal. So the principle behind hydraulic washing is, so this is the principle, okay. This principle is used to carry out the hydraulic washing, that is difference in the specific gravity. The density of the metal will be more, impurity will be less. So impurity will be washed away along with the water. That is what we call as hydraulic washing. Okay, you can read through what is given in the text. The second method is magnetic separation. What is the second method? It is magnetic separation. Okay, magnetic separation mein you have learnt it, that how the actually the device is working. There are two rollers over which a conveyor belt is moving. Okay, so you can draw this conveyor belt which is moving. Followed? There is a place where you feed the ore. Okay, one of the wheels of the roller, you will find electromagnet is being kept there. Okay, electromagnet is kept. So what happens as the ore is flowing here, the metal which is having magnetic property, suppose we are understanding that the metal is having a magnetic property, then that metal will be attracted towards the magnet which is there, and it gets collected at one end, while the impurities it will be drawn and collected at another end. Followed or not? और अगर तुम्हारा मेटल का है और वो मेटल मैग्नेटिक है नेचर में, दैट इज इट इज अट्रैक्टेड टुवर्ड्स द मैग्नेट, देन it will be collected at other end, while impurities will be collected, will be separated out. That is what it means. So I hope this is the this particular topic you have already studied earlier also. So what is the principle behind the magnetic separation? It is the difference in the principle behind the magnetic separation is the difference, it is the difference in the magnetic property, okay, magnetic property of the metal and the impurity. So impurity and metal, they have different magnetic properties. Metal अगर magnetic property वाला है, so then here you will have the metal being collected, okay, and if the impurity non-magnetic है, therefore it will be collected at the other vessel. So here you have your impurity. I hope it is clear. ठीक है, तो what is the principle here? The difference in the magnetic property of metal and the impurity. Suppose if impurity is magnetic in nature, then it will be collected, it will be attracted towards the electromagnet and it will be collected at one end, and the our metal which we require, it will be collected at other end. Okay, so this is magnetic separation. ठीक है, now coming to third one, which is called as froth flotation process for the concentration of sulfide ores. Okay, froth flotation process, and specifically this process is used for sulfide ores for the concentration of sulfide ores. Example जैसे ZnS हुआ, it is ZnS or maybe PbS, any sulfide ore you are concentrating by froth flotation method. Now here what is involved? There is a huge tank, okay. In this tank you are filling water, okay, you are filling water in this huge tank, and there is a rotator, okay, there is a rotator which rotates at very high speed. You can rotate this rotator, okay. So this is the rotator, these are the blades of the rotator, okay. And to this arrangement, here you are having water in it, okay. To this arrangement you are adding the powdered ore, okay, powdered ore. Now along with the powdered ore, what are the other things you are adding to it? You are adding collectors, or you can say frothing agents. Which are the various collectors I am writing here? Like pine oil, okay, pine oil हो सकता है, और xanthates हो सकता है, xanthates, or what is other one you can have, that is turpentine oil, या कोई भी fatty acids, okay, you can just write these three, that is enough, okay. Turpentine, xanthates, pine oil, they are all collectors, that is they froth, they have the nature of making the froth. So, how is this pine oil helping in frothing? See, powdered ore along with the turpentine or the pine oil, it is added to the water. Okay? This rotator is rotated at very high speed, that is water with pine oil is agitated. Agitated matlab you are mixing this thoroughly, rotating the blades and you are rotating this mixture thoroughly. So, what happens? Froth is formed. Froth matlab jhaag, and froth, it is being lighter, it will be formed on the surface of the tank. The ore particles which you have added, it will stick to these froth, the ore particles. The ore particles which are in the powdered form, it will stick to these froth, while the mud, sand and all, it will get collected at the bottom. Mud, sand, soil, clay, all those things, it will be collected at the bottom, while the metal particles, that will be stuck to the froth. Okay? Soil hai, then you have clay or whatever impurities you have, that is settled at the bottom, while the sulphide particles, this is what? This is the metal sulphide. You can say the metal sulphide is stuck to the froth. So, metals are concentrated, that is all this froth will be having now metal in it, while the impurities are settled down. Then this froth is removed, it is skimmed off from here, okay, it is collected, then washed again and then concentrated and solidified. ठीक है, तो ये जो process है, this is the frothing process where you get the metal sulphide stuck into the froth. तो यहाँ पे the principle involved is, what is the principle here? The principle here is the difference, it is the difference in the wetting properties. It is the difference in the wetting properties of the metal and impurity. Difference in the wetting property of the metal and the impurity, what does it mean? It means कि metal sulphides जो है, they will get wet by the froth, while the impurities are wetted by the water. Okay, so we can write here metal sulphides are wetted. Okay, metal sulphides are wetted by the froth. Froth is the foam or the lather which is formed, and impurities are wetted by water. Impurities are wetted by water. ठीक है? Now, one other very important thing to be understood here is कि ये जो froth है वो settle ना हो जाए. To stabilize the froth, there are certain materials added which are called as stabilizers. Okay, and the stabilizers of the froth are aniline cresol. Okay, so you add here stabilizers. I am writing it here. Okay, you are adding stabilizers, stabilizer of froth, that is aniline. Okay, aniline, or we can say cresol, CRESOL. ठीक है? So that is also added so that the froth remains as froth and doesn't settle down. Okay, so they are called as stabilizers of froth. Also, if your ore consists of sulphides of two different metals, then and you require only the only one of the metal, then how would you get one of them? Because if you are carrying out this process, then the whole of the sulphide particles will get stuck to the froth, but we do not want that. We want only the particular metal sulphide to get stuck. Then what is the process you should be doing? Then you should add a substance called as depressant, where the depressant will bond with or make a complex with one of the sulphide of the metal, and only frothing of the required metal sulphide will take place. Example, जैसे हमें ये जो powdered ore है, I am writing it here, okay, I am writing it here. Powdered ore has ZnS also and PbS also, both you are having. ऐसा ओर है जहाँ पे ZnS भी प्रेजेंट है और PbS भी प्रेजेंट है, और हमें सिर्फ PbS चाहिए. वी डोंट वांट ZnS because we want the metal Pb. Pb is the lead sulphide only we want. We don't want ZnS. So to this ore, what are we adding? We are adding a depressant. Okay, depressant like NaCN. So what will NaCN do? NaCN will make a complex with Zn and does not allow the frothing the material to stick to the froth. Okay, so here NaCN plus ZnS forms a complex. And it will not allow the ZnS to stick to the froth. Only PbS will stick to the froth. Okay, so that is called as the depressant, and the depressant which you are learning is NaCN, which is sodium cyanide, which depresses or which does not allow the ZnS to come into the contact with the froth, that is, it makes a complex, gets bonded with it. Okay, so these are the concentration methods which you have to learn. So concentration, after the concentration, then you can go for the further process. Okay, so this is the basically the three concentration methods. One more is there, leaching. First you copy down this, then we can go into the leaching process for the concentration of the ore. Okay, copy it. The next process of concentration is called as leaching. Okay, leaching. Now in leaching, the powdered ore plus a particular solvent, you can say. Okay, that solvent can be an acid or a base or any chemical. Any chemical it can be. You are adding the powdered ore into the solvent where only ore is soluble, only ore will be soluble. Yeah, it has a selective solubility. The ore will be soluble while impurities remain insoluble. Okay, only ore is soluble and impurity remain insoluble. Impurities remain insoluble. ठीक है, तो इसमें क्या हो जाता है, the impurities will be insoluble, it will be filtered out, and what you obtain is containing the metal ore only. Okay, or maybe some impurity, even if it is in the soluble form, it can be then removed by some other methods. ठीक है, तो let us take one example and try to understand. Usually leaching is carried out for aluminum to obtain the concentrated ore of aluminum. This you have learnt, Bayer's process, if you remember. Bayer's process is a leaching process. Okay, very important metals like gold and silver, they are also concentrated their ores are concentrated by the leaching method. Okay, so we will discuss those two processes. First, let us take aluminium ore. Which is the aluminium ore which we are usually taking? It is Al2O3 2H2O, जिसका नाम है bauxite. Okay. Now this bauxite, no, it is treated with NaOH, the solvent which you are taking. Okay, plus H2O you can write. This is carried out at a temperature of 473 Kelvin to 525 Kelvin. Okay, and a pressure of 36, or you can write 35 to 36 atmosphere is kept or bar is kept. ठीक है? When this is carried out, you will get two products. What is that? The NaAlOH4. This is sodium aluminate. It is sodium aluminate plus Na2SiO3, which is sodium silicate. अब ये Al2O3 जो है उसमें कौन सी impurities है? It has Al2O3. This is not the impurity, this is the oxide which we require. इसके साथ along with it we are having TiO2, that is titanium oxide. Then you have another ore oxide, that is Fe2O3. These are all impurities. Okay. Then you have SiO2. So these three are the ones which we call as impurities, because those are the metals which we do not require. So these are impurities. Okay. So when you treat aluminium oxide, that is hydrated form of aluminium oxide called as bauxite, with NaOH H2O, okay, you can balance it because 2Al hai. So you will get two substances in the solution, that is sodium aluminate and sodium silicate. जबकि ये जो impurities है ना, that is TiO2 and Fe2O3 remain insoluble. मतलब वो solid form में ही रहता है, it remains insoluble. So in the solution form you are having sodium aluminate and sodium silicate. ठीक है? You filter out, ठीक है? Filter. So these impurities will be removed. Fe2O3 and TiO2, you filter out, it gets removed. So now you have your solution which has NaAlOH4, okay, plus Na2SiO3. This is in the solution form. Okay. इसके साथ you are passing CO2 to neutralize नहीं, to adjust the pH, we can say, to adjust the pH. Okay, CO2 you are adding. Okay, so now you add H2 water. So what is happening when you do this? Gelatinous precipitates of aluminium is precipitated out. Okay, you get what? Gelatinous precipitates of AlOH thrice is obtained. Okay, that is hydrated form of Al2O3 only. It is the hydrated form of Al2O3. So before the gelatinous precipitates are coming out or are being precipitated, you add a small amount of Al2O3 into it, that is aluminum hydroxide, which is the process we call it as seeding process. Okay, just to initiate the precipitation of AlOH thrice. So, AlOH thrice, that is same as Al2O3 XH2O you can write, this is only AlOH thrice. Okay. This AlOH thrice, this is the gelatinous precipitate, okay, gelatinous precipitate which you obtain. This precipitate, then you heat it and then you get Al2O3 which is 99.95% pure. Concentrate हो गया, you have removed all the impurity, you are obtaining only Al2O3. अब ये Al2O3 में से you have to remove the oxide and that oxide is removed by Hall-Héroult method if you remember. Okay, electrolytic refining, that electrolytic separation that was done. Okay, electrolytic reduction we will call it because you are removing oxygen. So, it is a reduction process. Therefore, it will be electrolytic reduction since electricity is being used for the reduction purpose. Why can't we use carbon? First of all, aluminium highly reactive metal hai. The carbon will have more affinity for the oxygen than the aluminium. So, the reduction won't be carried out in that purpose. So, therefore, it will be carried out by electrolytic reduction. Okay? So, this is one of the leaching process. You have concentrated your ore. Followed. The other metals which are concentrated by leaching process are metals like Ag, Au are concentrated, okay, are concentrated by leaching, okay, by leaching. Say for example, if you are taking Ag, okay, Ag you are treating with NaCN, sodium cyanide, okay, it forms a complex NaAgCN2, okay. Along with it you are passing O2 also, which is the oxidizing agent. So, you get NaAgCN2, a complex will be formed, okay. So, this is how you can find the first the complex being formed. This is not a balanced one, you can balance it, okay, you can balance it by okay, also H2O is there plus O2 giving you 4 NaCN plus 4 times NaOH. So, this way you can balance it, okay. Whenever you are using silver ore, then you will use the solvent as NaCN. Similarly, you can also carry out leaching, or when we are carrying out the leaching process for gold ore, then you will use the solvent as KCN, okay, plus H2O plus O2 gives you the complex with gold, okay, that is NaAuCN twice, okay, plus KOH. Here again you can balance it, 4AgCN 8, 4Au plus 8KCN, 2H2O giving you 4. Followed everyone? तो इस तरह से कॉम्प्लेक्स पहले बना लेते हैं एंड देन व्हाट इज बीइंग डन, देन यू हैव made the complex and now this complex is decomposed by NaAgCN twice. You are treating with a reducing agent, here reducing agent is Zn, okay, reducing agent is being used and you obtain Ag as the elemental form, and this way it will get reduced. Similarly, AU can also be reduced in this manner. AU formed complex with CN, it will get reduced in this manner. Okay. So, this is how you can understand how the leaching process of AG and AU can be carried out. Okay. Followed everyone? तो ये तुम्हारा, मैंने तुम्हें रिडक्शन भी बता दिया, बट एक्चुअली दिस इज द कंसंट्रेशन ऑफ द ओर विच वी आर स्टडिंग अंडर द लीचिंग प्रोसेस. यहाँ पे तो मेटल तुमने रिड्यूस कर दिया, बट अप टू दिस पार्ट इज व्हाट वी कॉल एज द लीचिंग प्रोसेस. फॉर गोल्ड, फॉर सिल्वर, फॉर एल्यूमिनियम वी आर यूजिंग दिस methods for concentration of their ore, which is called as leaching. ठीक है. So today we have discussed all the concentration methods for the ore. 4 different concentration methods you have learned: hydraulic washing, magnetic separation, then you have froth flotation method and the leaching process. सबका principle we have learned. So there will be very small objective questions coming from this part. So you have to be very careful, and this leaching process very important. It can come as a short note, especially for the leaching of gold and silver. Okay, very important part. So that you have to learn thoroughly. Followed other processes which we have discussed here, you can have objective questions from that part. So that is how you should be doing your learning. Okay. So next time we can discuss how to extract metal from its crude, that is the concentrated ore. We won't say it as crude ore, we will say it as concentrated ore, extraction of metal from its ore. Okay? Thank you.